Good morning, everybody. Well, I guess good whatever time, everybody. In this video, I'm going to be doing section 10.1. It's talking about sequences and series. So again, like always, what we have to do is actually figure out what it's talking about when it says a sequence. Well, a sequence is an ordered list of terms. So what I mean by that is there's one very famous one. It's called the Fibonacci sequence. ACCI sequence. You see it a lot in nature. If you go look it up on Wikipedia or somewhere online, just type in Fibonacci sequence in nature. It'll show you a lot of cool pictures of how it applies in nature. Well, the Fibonacci sequence is 1, 1, and once you get the first two numbers, you're going to take the previous two and add them together. So now I'll do 2 plus 1 equals 3, 2 plus 3 is 5, 3 plus 5 is 8, 8 plus 5 is 13, so on and so forth. This is our sequence or an ordered list of terms. There's also a specific rule in order to get each term. Well, for this one, my rule would be a sub n equals a sub n minus 1 plus a sub n minus 2. What did he just write? Okay, so with this, if I see a sub n, that is the term value. That is what it is equal to. So this would be my first term, so I would say that is a sub 1. This is my second, so a sub 2. And I'm saying sub, a subscript, a sub 2. So a sub 3, a sub 4, a sub 5, a sub 6, a sub 7, and so on and so forth, right? Until a sub n. But it doesn't really stop, it keeps going, so there's no a sub n. But it's just saying all those terms after it. The n is what term number I am on. Whether it be the first term, second term, third term, fourth term, fifth term, sixth term, 20th term, whatever. That is your subscript value. What's the other thing? Okay, with this, I have a sub n, so in order to get any value, I use this rule. This is my rule. So in order to read this, notice it says a sub n minus 1. Well, if I say that a sub 3 is my a sub n, then minus 1, well, if I take away 1 from n, that would be that one. If I take away 2, that will be that one. So a sub n, to find this term, the next term, take your previous term, a sub n minus 1, and add it to your term 2 terms ago, a sub n minus 2. Yay! So let's explore some about actually working with sequences and series. Okay, so first we're just going to kind of look at series. It says find the next 4 terms. So in the part A here, I have 8 to 15, 15 to 22, 22 to 29. It looks like it's doing plus 7 each time. So it's adding 7, adding 7, adding 7. So if I continue that pattern, next number would be 36, plus 7 would be 43, and then 50, and then 57. There's my next 4 terms. Yay. This one, I have 4, then I have negative 8. Well, it multiplied by 2, but it multiplied by negative 2. Negative 8 to 16, also multiplied by negative 2, times negative 2. So if I 2 times negative 2 again, I'll have 64. Times negative 2 is 128, times negative 2, 256, times negative 2, negative 5, 12. Yay. Alright, with this one, notice it gives me the rule this time. So if it's asking for the next 4 terms, it's probably just asking for the first 4 terms because I don't have any. So if I substitute all of my numbers for n, say I want to know the first term, well, if I want to know the first term, notice that changed n to 1, so I'll change n to 1 on the other side, so 2 to the first minus 1. So my first term should be 1. So I have 2 to the first is just 2, minus 1 is 1. Same thing, a to the second, 2 to the second power now, minus 1. That is 4, minus 1 is 3. For the third term, again you do insert 3, 2 to the third is 8, minus 1 is 7. 2 to the fourth is 16, minus 1 is 15. Here would be my first 4 terms. Cool, make sure you guys write some notes off to the sides if you have questions so you can come ask me. All right, next thing we're going to talk about, we already talked about just a little bit, but it is a recursive sequence. That is actually what our Fibonacci sequence was. All this means is it's going to use your previous terms to determine your next term. So I wrote a little note down here. Usually you just think about it. But a sub n minus 1 would be the first term ago, or one term ago. A sub n minus 2 is 2 terms ago. A sub n minus 3 is 3 terms ago, right? So if you wrote your sequence, say we had a sub n. Well, the next one would be a sub n plus 1, a sub n plus 2. Previous ones, a sub n minus 1, a sub n minus 2, a sub n minus 3, so on and so forth in both directions to infinity. But that is only in reference to whichever one you are talking about. So let's actually just take a look at a few of these. They'll start to make sense the more that you do them. All right, go ahead and get this one down. Determine the specified term. So I notice it's asking me to find the fifth term. It gives me the first term, a sub 1 is 5, so I know my sequence will at least start on 5. Well, it gives me the rule, a sub n is negative 3 times a sub n minus 1 plus 10, and n has to start greater than 2. Don't worry about this too much. Pretty much all that says is that we already know our first term, so you're going to be starting from the second term and moving forward. Okay, so now to find the second term, a sub 2, if you want to, you can substitute that into your equation so that you'd have a sub 2 is negative 3 times a sub 2 minus 1 plus 10. Good morning, Jennifer. And then you have 2 minus 1 is 1, so you have a sub 2 is negative 3 times a sub 1 plus 10. Yay. You know a sub 1 is 5, so go ahead and substitute that in. So a sub 2 is negative 3 times 5 plus 10, which is negative 5, so there's your next term. Alright, so now that I know my second term, I can use that term to get the next one, because again, all this a sub n minus 1 means is use the previous term. So if I do negative 3 times negative 5, that'll give me 15 plus 10 is 25. If I do the same thing again to get my fourth term, notice I need to go all the way to my fifth, so I'm looking for this number here. Well, if I do negative 3 times 25, that is negative 75, plus 10 is negative 65. And then negative 65 times negative 3, what is that? 180, 195. 195 plus 10 is 205. And that would be my fifth term. Happy day. Alright, doing the same sort of thing in this one. Finding the third term. We're given our first term, we're given a rule, and it tells us to start when n is greater than 2. So again, don't worry about that too much. Don't let it freak you out. Your first term is negative 3. Now I'm going to take negative 3, because this is my a's of n plus 1. So I have 2 to the negative 3 plus 4, so 2 raised to the negative third power plus 4. Yay, I get 4.125. And then to get the third term, I'm going to take that 4.125 and do 2 to the 4.125 plus 4. Hopefully it'll give me an answer. Should though. I don't know why it wouldn't. And we got 21.448. Yay, third term. Next thing and last thing we're talking about is the sum or partial sum. This s with an n just means sum of how many terms in the sequence. All you're going to do, don't forget sum is addition, so you're going to add the terms in the sequence. This thing right here, this is sigma. That is a Greek letter. It has come to be used for sum. So this is our starting term. Starting term. Whoa. And this is our last term. And then just like always, this is our rule for finding the, whatever they are. What are they called?
What?
The values of the terms. Ha!
Sigma. If you're doing the sigma thing, use the calculator. Super fast.
Yeah, you just know you can't always use it.
What do you mean?
You won't always be able to plug it in if it's a recursive sequence.
What's that?
The a sub n minus 1, a sub n minus 2 stuff. When you have to use your previous terms to find the next ones.
Yeah, okay. So it's only when it's that equals the number.
Yeah.
Interesting. But still.
It's always a good time when you look up monkeys. Ah, look at that one! It's like an old man monkey. That one looks weird, but he's flipping us off, so that's not good.
This is what you do in the morning?
No, bad monkey! No, I'm making a video.
Okay.
It's not a monkey at all. Cheaters.
Which one?
There's a baby in a monkey suit.
It's a lie.
Skip this part. Oh, look at that one!
A baby in a monkey suit?
Oh, that poor monkey. He doesn't even know any better. Oh, I feel bad. Ah! Using technology.
A onesie.
I'm sorry that I'm wasting so much time with this. I apologize.
Are you still recording?
Yeah.
Oh man. Second video.
All right.
Test.
Okay, and this one, find the sum. So we're finding the sum from the third term to the fifth term. So I will need to find the third term, the fourth term, and the fifth term, and add them all together. We'll use your rule. So if you plug in 3, you have 3 squared, which is 9, plus 2 is 11. So that would be 18, 27. 11 plus 18 plus 27 is 38, plus 18 is 56. Yes. Buzzed. All right, if it says find the fourth partial sum, scared you. So find the fourth partial sum. All that's asking you to do is find the sum from the numbers 1, 2, 4. So from your first term to your fourth sum. Fourth term. I can't speak. My ear hurts. I don't want my ear to hurt anymore. It's just that winging
Go to
thing.
the doctor.
No.
Why not?
Doctors smell funny.
You're probably my weirdest teacher.
Thank you.
You're welcome.
So if you plug in 1, you have 1 times 1 minus 0. 1 times 1 minus 1, which is 0. It's a 0. 2 times 2 minus 1. Hey. Hey. Don't die.
I'll try.
2 plus 6, 12. 20. Hey! God, I almost slapped you.
Yeah,
I would get in trouble. Yay? Yay. Morning.
I've heard that outro of your videos too many times.
You're welcome. Okay, so this one, if it says sum of 4, it is asking for the 1 through 4, first 4 terms, kind of like your fourth partial sum. We are given that a sub 1, your first term is 12. Yeah, I found that one. Now I need my second, my third, and my fourth. I'm going to add them. Add them. Oh, yes. So pretty. I think she tooted. So, if all that says is take your previous term, you have 2 times 12 is 24, plus 7 is 31. You did it.
I'm really surprised.
I'm not surprised. 2 times 31 is 62, plus 7 is 69. And then 69 times 2 is that 120 plus 18, 138, 145.
No, it's not that hard.
So then just add those numbers together. What is that? 100, 245, plus 12, 257. Yay, happy day. Hopefully you guys understood everything, and you like monkeys and drawing them and making them hold bananas and then doing a dance party. Dance party! Bye-bye!